Cylindrical mug has radius 5 centimeters and height is 9.8 centimeter, is full of water. A solid in the form of a right circular cone mounted on a hemisphere is immersed into the mug. The radius of the hemisphere is 3.5 centimeters and its height is 5 centimeters. Find the volume of water left in the tub. Now first draw the diagram to understand the solution. A cylindrical mug, it has a 5 centimeter radius and height is 9.8 centimeters with full of water. As you know, when you drop a solid in the water, then some water will flow outside. Okay, now the question is, find the volume of water left in the tub. Now write the measurements. What you can see in the diagram, cylindrical solid is given, radius 5, height is 9.8 centimeters. Okay, next cone height is 5 centimeters, radius is 3.5 centimeters. Hemisphere is radius 3.5 centimeters. Okay, next the volume of water left in the tub is equals to volume of cylinder minus volume of cone minus volume of hemisphere. So volume of cylinder is pi r square h minus volume of cone is 1 by 3 pi r square h and volume of hemisphere is 2 by 3 pi r cube. So among these three formulas, you can find some terms are common, that is pi. You can't take radius as a common because the radius of cylinder is not equal to the radius of hemisphere. Now pi you have taken the common, then the remaining is r square h, which is related to the cy cylinder, and in this second formula r square h by 3, which is related to the c1, and the remaining is 2r cube by 3. Now you know the pi value 2 by 1. R square, radius of the cylinder, 5 into 5 into 9.8. Point deleted, then you will get 10 minus r square h. R square is nothing but the radius of hemisphere, 3.5 into 3.5. H is a cone, height of the cone is 5 by point deleted 10 into 10 into 3 minus r cube 3.5 whole cube by 3. Now the simplification, 22 by 7, some terms are common, delete it or cancel it, then the product of the remaining terms is 245 minus same thing done in the second term, 245 by 12 minus, here the multiplication is 343 by 12. Now 12 you can take the common LCM, 12 into 245 is 2940 minus these values. So when we subtracted them, 22 by 7 into 2352 by 12. So after simplification of these fractions, 22 into 28 is remaining. The multiplication is 616 centimeter cube. Shaped cylinder, diameter is 12 centimeter and height is 15 centimeter, is full of ice cream. It has to be filled, height 12 centimeter, diameter 6 centimeter cones, making hemispherical shape on the top. Find the number of ice creams can be prepared from this container. First, you start drawing the picture. Okay, what is given? Cylindrical container is in the shape of cylinder and it is converting into the cone ice creams. As you know, cone is having the hemispherical shape on it. Then how many cones can be prepared? So first start with, let us assume number of ice creams is equals to n. So this is the diagram. Cylindrical, write the height, radius, and radius is 3, height of the cone is 12. So volume of cylinder is equals to n into volume of cone plus volume of hemisphere. As you know, this total ice cream has to be filled into the cones. Therefore, only their volumes will be equal. So here number of ice creams are n. So here the formula is pi r square h is equals to n into 1 by 3 pi r square h, which is the volume of cone, plus 2 by 3 pi r cube, which is volume of hemisphere. Now you see what you can take common from the both terms, n and pi. Okay, pi is the common from the both formulas, r square h by 3 plus 2r cube by 3. Here pi you can cancel because pi is the constant 22 by 7. And here r square, r of the cylinder 6 into 6, h 15 is equals to n into r square h, r of the cone 3 into 3, h of the cone is 12 by 3 plus 2 into r cube, 3 into 3 into 3, 3 times by 3. So do some cancellation which is possible, and 6 into 6 into 15 is in the LHS, and is equals to n into the simplification of first term is 36 and plus 18. This total is 54 transposing to here. 6 into 6 into 15 by 54, cancellation is how much? What is the cancellation of that? N is equals to 5. Okay, but remaining number is there. 5 twos are 5 twos, I think that value will be the required answer. Some more formulas you will see like this. A cubical wax is changing into the cylindrical candles. So the question is how many candles you can prepare. Then this wax is melting and changing into the cylinder. Therefore, their volumes will be equal. Then you will write formula like this. Volume of a cuboid L into B into H. You will have all the three measurements. Next is equals to N into volume of cylinder. Pi r square H. Okay, next cube is changing into the sphere. So volume of cube is equals to volume of sphere. Okay, next a sphere is changing into the cylinder. Volume of a sphere is equals to volume of a cylinder. Suppose the three small spheres are making a big sphere, are changing into a big sphere, then the volume of big sphere is equals to volume of small sphere 1 plus volume of small sphere 2, volume of small sphere 3.